Welcome, good morning, attempt number 2, episode number 47 of Coding Rainbow. Please let me know in the chat if the sound issues have gone away or if they are still here. I had such a good beginning. I was saying things that were important and meaningful. Sound is better. Great. Okay, so welcome. My name is Dan. This is Coding Rainbow. I am live on Monday, June 28th. Yes, 2016. Welcome. Good. Insert your time of day here. This is just. Okay, I failed. Anyway, so I'm here, I'm live. I am going to talk a bit about code and various things. I have a project that I have in mind that I'm going to do today. And in a moment, I'm going to show you what that project is. But before I get started with that, I just want to take care of some kind of introductions and logistics and administrative stuff to introduce what's happening. So first thing is, if you happen to be watching this as an archive, please look in the video description. There will be links there to various things that happen during this video, and then also the certain segments that happen in the next hour or two that I'm here live will get turned into edited standalone tutorial videos, which you can go and watch separately if you want that sort of thing. So it's a Tuesday. Did I say Monday? Today's Tuesday. In the future, no one will really care or know, but today is definitely Tuesday. I was thinking it was Monday because I aspire to be here on Monday, recording live, but somehow I couldn't make that happen. So, okay, so the first thing I want to do is welcome anyone who's new here. There is a live chat. You can ask questions in the chat. The chat is on YouTube. I also am broadcasting to Twitch and Facebook, but I'm generally not paying attention to those channels, and at some point I might just eliminate them, but right now I'm kind of just broadcasting everywhere. And what I do in these sessions is talk about various topics related to what might be loosely called creative code. And today's topic, which I will get to in a moment, I didn't use any of my sound effects.
Hello.
Can you hear those? Good morning. Okay, I don't really need the sound effects today, I guess. Today's topic will be something called a supershape, and which is based on this really weird looking, uncomfortable looking math formula. So I have covered this in previous segments, episodes. I talked about something called a super ellipse when the camera turned off. Here we go, turning that back on. I have talked about the super ellipse. I have talked about the supershape in 2 dimensions, but today is the day. Today is the day where, scrolling down here, I'm going to show you how to make some of these patterns in 3D in processing. So that's the main topic for today. The way that I'm going to approach that is, first I'm just going to look at how do you draw a sphere in 3D, because you really need to understand about latitude and longitude and spherical coordinates. Once we have that, these shapes are really just strange distortions of a sphere. So that's ultimately what I'm going to get to. Now I want to point out to you guys something if you haven't seen. Riza Ali, who is a computational artist, apparently somebody who maybe also works at Goldman Sachs, Supershape, created some wonderful artworks based on these Supershape formulas. I'm going to click over to his website and page. Maybe I'll just play this video for a second. So ultimately, this is the idea. This is a beautiful. You can see this project. There's all these parameters. Maybe I can make this full screen. There's all these parameters that are being tweaked, and there's colors and shading. And so I don't know how far I'm going to go ultimately today, but I'm going to give you the necessary tools and ideas needed to essentially do this kind of thing. And it's up to you what type of creative applications you might do with that. You know, on the one hand, you might try to build an interface to sort of play with it. You might play with different ways of coloring it, texturing it, lighting, types of 3D things. I am going to do this today in the processing programming environment, which I know has a very robust and working 3D engine. And once we get that finished and we have working code and we see that it's working properly, I'm going to make an attempt to see if I can do this in the browser using p5.js and its kind of new WebGL rendering engines. We'll see how far we get with that. Okay, so that's the plan. That's my plan. So, okay, I'm looking at the chat. If you have comments or questions, please weigh in. Now, there's a couple other things I want to talk about. First, I have a new system for discussion of topics and questions to be answered on my live broadcasts. And so if you go to github.com/codingrainbow, so this is now a GitHub organization. It has one person involved in it, which is me. At some point, I hope to expand the Coding Rainbow universe to have something that resembles an actual rainbow. In other words, people who come from different backgrounds and countries and thoughts maybe participating in this channel in interesting ways. But right now, it's just me. I am a rainbow. I hope I aspire to be one at least. That doesn't make any sense. Anyway, so all of the code that I ever do online is here in this repository. This is a repository that I aspire to have full. I would really like to do closed captions for every single video I put online. Right now, I'm not really breaking even on the amount of expenses I have to produce this channel versus what I have coming in from the Patreon support and YouTube advertising. But once I get a little further along with that, I'm going to start paying for closed captioning. So, so in that sense, I'm keeping the captions here. You can see I have captions for some. They look like this, by the way, if you're interested. These are what the captions look like for some of my other videos. And then, of course, translations would be nice too. But anyway, that's in the future someday. But the place that I wanted to show you here is Rainbow Topics. So this is a repository, but I'm not really using the repository for anything. You'll note there's no code in this repository. There's a little README page here that explains some stuff, shows you a little image, and has some links here to my Patreon, Coding Rainbow website, and the YouTube channel. But this is the important thing. Here is what I now think may work well for me keeping track of a list of topics as well as some form of upvoting and commenting on those. So you can see to suggest a topic, all you have to do is go to codingrainbow/rainbow topics. I'm going to do this right now. I don't actually think the Supershapes is in here, so I'm going to just do this live. I'm going to go, whoops. I'm going to go to, this new issue right here. And then I'm going to over here say, Supershape. Supershape 3D. I would love a video tutorial on the Supershape 3D. And then I would go and also say, like, here's some inspiration. Here is some inspiration. That Paul Bork link, the Riza Ali link. And I'm going to hit submit. And now there is an issue that I can keep track of. So I see it, I've registered it, and then when I actually make somebody thumbs it up it, which is what I'm going to talk about in a second, you can ask a question, leave a comment, and then ultimately once I make the tutorial, I will then come back here, post a link to the YouTube video, and hit close issue. So, oh, come on, thumbs it up again. Okay, thank you. Now, a couple more things I want to say about this. One is, if you want email notifications for when topics get suggested or comments on topics get posted, you can go here to this watch, and you could say watching. You could select watching, which will give you notifications. You can also subscribe to individual threads down here on GitHub issues, and then you can also here add a reaction. So what I'm choosing to do is, if you see an issue and you're like, oh, I would love that to be a topic as well, click the thumbs up reaction. And what you'll be able to see that I can do is when I go back to the issues list, I can go under here under sort, and I can sort by most reactions, most thumbs up. And you'll see now, you'll see the list of topics ordered by the number of thumbs upness. So in that sense, and I could look here and see like, okay, this is how many people have thumbs up it, this is my list. So this is going to help me, you know, I'm not going to make decisions exactly based on this as some sort of like pure voting system because, you know, there's other interests at play in terms of what I have time for, what I'm doing in other projects, but it gives me a really good sense of what people are interested in. It's a place to have discussion about this stuff, and so that's that. Now, two other things I want to say about this. The other thing is, and I'm going to do this right now, I want to create also a label. Somebody in the chat maybe, you know, these, there could be topics. It's a gray area here, it's a fine line. But so something you might suggest might be a topic like the Supershape or Chrome extensions. But you also might have a question. Somebody asked me the other day, like, what is the difference between P5.js and processing? Now this is a very broad, large question, but you could also submit this as like a question, and I want to add, what I want to do is create a label. So I am going to, go to settings here, no. Issues, labels, no. Where do I manage my labels? Here we go, labels. I'm going to create a new label called Q&A. I'm going to make that, sure, that's a fine color for it. Create label. And because what I also want to do is allow people to sort of also just ask free-form questions, almost like, you know, if it can even be like about a particular piece of code. Like you can post a piece of code, I have a bug in this code, I can't figure out why. So just general Q&A questions can go in here too, as well as topic requests. Because I have this, on the YouTube, I have a playlist called Q&A where I'm kind of answering questions from the audience, so to speak. But I only have one video so far, so I want to be able to do that as well. There's already a, Oliver says, there's already a question label. That was silly. Okay, so let me go back here. Labels. Yeah, so there's a question label, so I should just use that one. Forget about this silly Q&A. And so we'll use the question label. I'll figure that out later. Anyway, if you have suggestions for labels, please let me know. Okay, so that's just about all I have to say about this system. I've tried a few things, and I think this is going to hopefully work pretty well. Mostly, it's a place that I can look for ideas of what I want to do on the stream. The last thing I'll say about this, just briefly, is that once again, if you want to have more discussion about things that are going on the channel with a smaller community of people, you can go to codingrainbow.com and click on Become a Patron. Become a patron at the Patreon service. It's a kind of crowdfunding system for content creation, and there's information about that if you want to join up. And I have a Slack channel where we also discuss topics and answer questions and have just general creative coding discussion there. So that's also something that's available to you. Finally, I always get the question of how do I know when you're going to do a live stream? Also on this codingrainbow.com website, there is a place where you can put your email, submit, and I'm not so great about this. I just sent out the notification for today this morning, but it is a place where I will send email notifications. I also should let you know that I am planning to do a live broadcast this Thursday. So I'm doing 2 this week because next week I will be away, so there will be no live broadcast next week. But there will be 2 this week. And I don't know what the topic will be this Thursday yet. So make your suggestions on GitHub, give your thumbs up, and be in touch with me on Twitter and all of that jazz. Okay. I see there's some questions. Oh, yes, F Looper. I do remember you and your crazy song. Oh, let's play F Looper's crazy song. How do I find it? SoundCloud F Looper. Let's see. I think this is going to be it. Let's play the crazy song. Okay, here it comes.
So this is random. This is noise. Perlin noise, that is. In the core.
I think I'm blowing out your ears. Oh. Hello? Was the audio of that okay?
Random algorithm, the actual random algorithm itself, those numbers aren't related at all. You pick, like, I'm picking random numbers between 0 and 10. 9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1, 3. I pick 9 a lot, apparently. But with Perlin noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5, 6.
Yeah, why is it so loud? Okay. Hold on. I think, though, I have a larger sound issue that I should fix. Let me just double check here. Ah, it's not turned down. When I restarted the computer, I lost my sound settings. Okay, so that helped notice it. Okay. And now, whoops. And that should have fixed that. Hold on, whoops. Hold on, everyone. I'll be... Please bear with me. Oh, that one was right. Okay, I don't know what happened there. Okay, here we go. Back.
7, 8, 9.
That should be better.
7, 6. Boy, this is like Perlin Noise performance art. 9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1, 3. I think 9 1. 2, 3, 4, 3.
I have something that I think I should do here.
Boy, this is like Perlin Noise performance art. 7, 5, 9, 2, 7, 6, 1, 9, 4, 8. But with Perlin Noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5. Perlin Noise, that So this is random, this is noise, that is Perlin noise. So this is Perlin noise, that is Perlin noise. This is Perlin noise, that is Perlin noise. So this is Perlin noise, that is Perlin noise. Perlin noise, that is Perlin noise. So this is Perlin noise, that is Perlin noise. This is Perlin noise, that is Perlin noise. So this is Perlin noise, that is Perlin noise. Perlin noise, that is Perlin noise. So this is Perlin noise, that is Perlin noise. This is Perlin noise, that is Perlin noise. So this is Perlin noise, that is Perlin noise, that is Perlin noise. So this is Perlin noise, that is Perlin noise. This is Perlin noise, that is Perlin noise. So this is Perlin noise, that is Perlin. Apparently. But with Perlin noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5, 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5. Boy, this is like Perlin noise performance art.
Okay. That's enough. Let's move on. I'm going to do the Supershape today. Okay. I hope you guys enjoyed that. I'm losing my mind, but having lots of fun. You can always turn this off. I highly recommend doing so. It's getting, now I'm getting a little bit hot. I'm a little verklempt here. Okay. Okay, yeah, somebody can make that a nice music video. Seb in the chat writes, my brain only has room for this dance or actual knowledge about Perlin noise. Bye-bye knowledge. I'm glad. Okay, so let's get started here. It seems very sad to now be talking about spherical geometry when I could just continue the dancing the whole time. So what I'm going to do here is open up processing. And I'm going to start getting ready. I think what I'm going to do is the first thing that I'm going to do is look at how to create a sphere. So what I want to do, I think, is let me open up. I made a version of this last night, and I don't remember where I saved it. I don't think it's actually here, even though there is something that says Supershape 3D. No, okay. So hold on a sec. So I was probably just saved this in. I'm looking right now for the version I made last night. Whoops, no, that's not it. Supershape. By the way, thank you, Oliver. You can see this is Oliver helped me with this, and he made a more complex version. And now, okay, let's see. Let me just see if this was. Yep, this is the one that I'm looking for. Okay, so this is ultimately the example that I made last night, which I'm going to build up towards showing you how to make. I feel like this needs music with it too. Whoa, I am the Supershape. That's the voice of the Supershape, in case you were wondering. Supershapes have a voice. And okay, so what I forgot why I was looking for this. Oh, because I want to have a reference on the screen, I think, for when I begin the first tutorial. So the first tutorial, what I'm going to do, and let me just add a little bit of code here. And okay, the other thing I need to review in my head here, and let me come over and use the whiteboard with you guys for this. Okay, so let's say you have a sphere, and I'm going to do this twice. Right now I'm going to practice it, and then I'm going to do it again, like kind of recording it as a video tutorial. So let's say you have a sphere, and I'm going to kind of draw it like this. Let's see how this works. Kind of like a basketball-like looking thing. And I could also kind of think of it as a grid. So I can think of a sphere as like a grid, and this grid is almost like I'm taking it as like it's a piece of paper. Like it's this. Like it's this, and then I'm going to wrap it around. I need like a spherical object. I'm looking around. I don't have a spherical object. What would I have that would be? I have a bicycle helmet. This is as close. This is probably a bad prop. And then I'm going to take this and like kind of wrap it around it. So that's not really going to work. So that won't really work in my demonstration. But the idea here is that I'm taking this and I'm like wrapping it around a sphere, a globe, and then oh my God, how come I can't figure this out? Latitude and longitude. These lines, the horizontal lines are the longitude, right? Like the equator is longitude, and these are like latitude. Is that really right? Because, well, no. Longitude goes around like this, but that's really then the vertical lines. Because what I'm trying to say is, which longitude am I at, which is like around. So that's really like the columns. And then the rows is latitude. Where am I vertically? I think that's right. I just look up on Wikipedia here, okay? So let's see. Latitude is lateral, Darth Torres. Longitude goes up and down. People are writing in the chat. Is that what I just said? Longitude, it goes up and down, but the lines go up and down. So, oops, I'm in the wrong place. The lines go up and down. So that's longitude, right? It's which longitude am I at? Latitude is which latitude am I at? Let's just look at a, Okay, this will be a nice website that I'm sure will give us a nice pretty picture. Boy, this is no good. Oh, here we go. Right? These are the longitude values. These are the latitude values. The equator is latitude. Yeah. The equator is latitude. That's what I'm saying. The equator is one of the latitudes. But the latitude that you're at specifies kind of where you are. Anyway, okay. Am I saying it right? Okay. So that's one thing we need to figure out. So what and your longitude values go between negative pi or negative 180 and degrees and 180 degrees. And then your latitude values go from a negative 90 degrees to 90 degrees, or negative pi divided by 2 to pi divided by 2. So what I need to establish is a loop. Essentially what I want to do for every point in a sphere is do a loop for every longitude value, check every latitude value. Equatitude, quackitude. Okay, so that's where I need to start. Okay, I'm going to erase that. So I think I might actually be ready for just doing the sphere geometry tutorial. So the other thing we need for this, let me get a web page up with this, is spherical coordinates. So just like polar coordinates are a radius and angle, right? This I feel more confident about. So let's just let's look at this here. Let me just get the formula. Did I miss it? Where's that formula? Ah, here it is. Nope. This is what I want. Okay, this is what I want now. So ultimately, there's theta and phi. Is it phi or phi? It's phi, right? Phi? I can't remember my Greek. So the issue that I need is which one of these I forget is latitude and which one is longitude. I think theta is latitude. Is that right? Let's see. Yes, theta. No, theta is longitude. This is longitude, and this is latitude. Okay. So then these are the formulas that will get us from a longitude and a latitude to an XYZ point. Okay. I say phi like Bill Nye the Science Guy. Excellent. Okay. I think I'm in good shape for the spherical coordinates tutorial. Darth says phi like phi. Phi. All right, I don't know what it should be. All right, let's see if I can find a pronunciation of, because you know in the YouTube comments people are going to yell at me for getting this wrong. Oh, here we go. How to pronounce. I don't know. Is this a problem that I'm playing somebody else's? Oh, wait.
Phi.
The letter phi is always pronounced phi in Greek, and it does not differ if followed by a vowel or consonant. So there you have it. While a linguistic purist might opt for the original Greek phi, most mathematicians know phi as phi. Well, that doesn't help me at all. Yeah, so Oliver writes in the chat, these formulas aren't the same as the ones used in Supershapes 3D. I noticed that too. And I was going to maybe worry about that in a moment. I think you might just be able to do either if you like flip the sines and cosines and you still kind of get a sphere. But I'm a little bit concerned about that. But I think I should use the formulas that are on that Wikipedia page, at least when I'm starting with the sphere geometry. And after I get the sphere, I'll take a break and kind of look at what might be going on there. Okay, I'm going to say phi then. I am not most mathematicians. You know what I'm going to do? I'm going to say lots of different things. Phi and phi. Phi, phi, fo, fum. How about that? Okay. There we go. All right, so the first thing we're going to do, let me leave this and this here. Oops. I'm not going to do any derivation of these formulas? Oh, because it's based on elongated spheres and you get 2 radii. Okay, that makes sense. I'm just going to say that. You remind me of that fact. I'm blowing my nose. I forgot to mute my microphone. I had a really bad cold last week, and I really felt like cloudy in the head. I don't feel that way at all today. I feel good, but I'm still a little bit drippy here. Phi, pronounced fun. Okay, we got to get started here. It is already 1:15. I'm going to cycle my cameras. It's quite hot in this room already, but I don't care. I'm getting ready. I'm going to play a little music. Get warmed up. Okay, and now it is time for me and you to make, oh, I need a drum roll sound effect. I need a drum roll sound effect to make a sphere. Okay. Purple sphere. We got my purple pen. I have no text messages. And I procrastinate so much here. Okay. Yes. So, okay, so this is I'm gonna leave this open here. Actually, I'm gonna leave this here. Okay, so I just need processing open. And I need this. And let's see here. Let's go to the, okay. Okay. Okay, everyone, let's see. Here we go. Oh, yes, I am. I forgot. I almost thought I forgot to record this whole session to disk, but I am recording to disk. You know, YouTube saves it, but in theory, the quality I'm saving to disk would be a little bit better. Okay, here we go. Where do I start? Oh, you. Okay. I'm just thinking. I'm thinking. I'm thinking. Okay, I'm ready. Hello, welcome to another coding challenge. This coding challenge will happen in 2 parts. It actually picks up from 2 previous videos, all leading up to eventually making this thing over there that's kind of undulating, oscillating, called the Supershape. So I'm going to get to the Supershape, not in this video, but the one that follows this one, because the first thing I need to do in this particular video before I can figure out how to make the crazy looking Supershape is simply just how to draw a sphere. And I'm going to do this in processing, which is a Java-based creative coding environment. Now, first, I should mention, if I just want to draw a sphere, I can actually do this really easily. So here, I'm just going to say setup. I'm going to say size. Let's have a nice window that's like 600 by 600. And I'm going to use the 3D rendering engine, P3D. In draw, I'm going to say background 0. Then I'm going to say, I like to just, I'm feeling giddy while doing this. I'm going to say fill 255. I'm going to say translate width divided by 2, height divided by 2. And then I'm just going to say sphere. And I don't know, I'm going to say like 200. And then I'm also going to say lights, camera, action. And then I'm going to run the sketch. And there I have, come on. Oh, and then look, I have a sphere. So this was actually really, really easy to draw a sphere because processing has built into it a function called sphere that will just create a sphere. But you'll notice the sphere isn't actually a sphere. I mean, of course, it's not anything at all. This is like pixels in some sort of like YouTube space, and maybe I'm just pixels in somebody else's imagination. I don't know. Maybe everything we are is some kind of weird computer simulation, and I think I've lost track here. Back to what's at hand. What it is it's a lot of triangles all placed next to each other. And you can see those triangles if I zoom up here. And these are actually known as triangle strips because of there's these horizontal or vertical strips of triangles. So what I want to show you in this video is how to draw these triangles yourself. Because if you can draw them yourself, then you can start to move the triangles around so they undulate. You could color them with different colors individually. You could texture them with an image. There's all sorts of types of things you can do. And ultimately what the Supershape is it's like having this sphere, but taking certain points of the sphere and pulling them out and pushing them in based on some other math. So that's what I want to do in this particular video. Okay, so what's something that we need to become familiar with? So one thing that I think that would be worth discussing briefly, awkward shuffle this way, button press. Hello, hello, we're still here. Would be to talk about how do we think about, talk about, and consider the points on a sphere. So you've probably heard of something that always completely confuses me, and I get it backwards, I would say about 75% of the time that I talk about it, and hopefully this is going to be the 25% of the time, but you've probably heard of something called latitude and longitude. So if you think about the Earth as a globe, and I could draw the globe here as like, here's a circle, this pen is not so great, and I could kind of draw these strips here, trying to use my best artistic talent to make something that looks 3D-esque. And you can think of this in a way as like, okay, there is a grid of columns and rows. And if we were to take this flat two-dimensional grid and take it and kind of wrap it around a sphere, you know, this way, this is like the map of the Earth that we've taken and wrapped around a sphere. And each point along the sphere is represented by a longitude, meaning which one of these columns, so to speak, by a latitude, which one of these rows, so to speak. And the latitude in the middle is, you know, referred to as the equator. Now, these can be, you know, there's lots of different ways of kind of measuring latitude and longitude, minutes and seconds, and there's the prime meridian and all this stuff. I would love to do another video about mapping. I think I will get to that at some point. But for us right here, the measurements that we're going to use are angles. It's kind of an angle of rotation, you can think of it. And longitude goes between negative 180 degrees to 180 degrees. And latitude, right? So that's a full kind of 360 all the way around that globe. But latitude only needs to go between negative 90 degrees, 90 degrees and negative 90 degrees. So these ranges will cover every point on the globe. And there's some nuance to this, but I'm kind of doing this in a sort of basic, pure, loose way. So what I need to do is have a loop, just like you might have a nested loop for pixels, knocking over cameras, just like you might have a nested loop for pixels, pixel 0, 1, 2, 3, 4, 5. What I want to do is have a nested loop for longitude values and latitude values. Hopefully I got this right. I'll redo this video or put lots of YouTube annotations all over it. People on the internet are really going to get mad at me if I get this wrong. Okay, so what I'm going to do is I'm going to now get rid of this line of code that says sphere 200. And what I'm going to do is I'm going to say, and you know what I'm going to do? I'm going to do something strange. Instead of actually doing my loop from negative pi to pi, or negative 180 degrees to 180 degrees, I'm going to do something a little different. I'm just going to say I goes from 0 to like 100. And then I'm going to have a nested loop inside that. J goes from 0 to 100. And what the 100 is kind of going to refer to is how many points. What's my detail level of this sphere? And actually processing as a sphere detail function that can set that for the automatic spheres that are drawn. So like how like fine is the resolution? How many points across, how many points below? So I'm going to do that. And then what I want to do is then take every I. So let's have I be the longitude values. I think that'll make sense. So I need a longitude value, which is mapping I from 0 to 100. And let's make that 100 a variable. So I is between 0 and each one of those should then map to the range of negative pi to pi. And then the latitude should map between negative half pi to half pi. Okay? I think I'm doing pretty well here. And I'm going to change this to total and total. Now, oops, and I'm going to save this as sphere geometry. Okay. So now I need to do something more. So let me just run this to make sure it doesn't crash or give me any errors. Okay, so this seems reasonable. It's working. Now here's the thing. What I need to do is take those, each one of these latitude and longitude values, which we can think of as a pair of values, and have some math to convert that to an x, y, z value. Now this is something quite similar to what I've done before. And actually, by the way, this should really be written like this. R, comma, latitude, longitude. Because I really have three values, R being the radius of that sphere. This is very similar to something I've done in previous videos. If I have R and theta, a radius and an angle, I need to convert that to an XY value. This is kind of polar coordinates, right? If I have a radius and a theta, I need to convert that to an X and a Y, and there are formulas for that. X equals R times cosine of theta, Y equals R times sine of theta. Now, if this polar to Cartesian coordinate transformation is unfamiliar to you, I would suggest looking at one of my previous videos where I covered that in more detail. But what I need to do is essentially apply the same kind of math, but it's a bit more complex math, because instead of having, I have one radius, but instead of one angle, I essentially have two angles. And the results I want, instead of having an X and a Y, I have an X and a Y and a Z. So let's go and look at how that works. Okay, so there's a nice place on the internet, you may have heard of it, where I could find those formulas. It's called Wikipedia, and I have them right here. And these are the formulas for converting from latitude and longitude, and I believe in this case the theta refers to longitude, and the phi or phi symbol, phi, phi, fo, fum symbol refers to, it's the Greek letter phi, but I think it's often informally pronounced phi, I don't know why, is latitude. Hopefully I got that right, and when we find out that I got it wrong, we'll fix it. Okay, so these are the formulas I need. X equals R times sine of longitude cosine of latitude. So let's put that in to the code. X equals R times what? What did I say? Sine of longitude times cosine of latitude. You know, I'm not deriving these formulas. I don't know that I could just do that off the top of my head right now. If people are interested in that, I could make a sort of side video. And then Y equals R times sine of longitude, sine of latitude. Sine of longitude, sine of latitude. And Z equals R times what? Cosine of longitude. And what is R? Well, by the way, when I drew the sphere automatically, I gave it a value of 200. I'm pretty sure that would be the radius. So what I want to say here is float R equals, I'm just saying to remember what I'm doing, 200. Okay, so now we should have a longitude or latitude mapped in a nested loop and calculate an x, y, z. So let's do something simple and just say stroke 255 and say point x, y, z. And let's hope that we get something that looks like a sphere. Ooh, no. That doesn't look right at all. Ooh, interesting though. What did I do wrong? Okay, time out, pause. I'm going to do some debugging, or keep going, I'm not sure. Okay, maybe I typed the formula wrong. Sine, cosine, sine, sine, cosine. Sine, cosine, sine, sine, cosine. Did I get latitude and longitude wrong? No. Oh, this says I there. No wonder. There we go. Now, okay. Okay, back after debugging, I had a really silly error here where I was using I in both of the loops. So I is the value that's going across for all the longitudes, and J is the value that's going down for all the latitudes. And by the way, if I want to calculate my latitude, I need to use J. So now we should see, what do I get? These are all the points of a sphere. Now, it's sort of hard to see that this is a sphere because it kind of just looks like a lot of points in 2 dimensions in like these radial circles. So one thing that I'm going to do to be able to manipulate this scene very quickly and easily is add a processing library called PZCam. I've shown in other videos how to install it, but so I'm just going to go here. I already have it installed. I'm going to go here and import PZCam, and then I don't actually need all this. Then what I'm going to do is I'm going to say I need to create a PZCam object, which is a camera. I'm going to say camera equals a new PZCam. This, so that it controls this sketch, and 200 because I want my view to be about 200 kind of 3D pixels away. And once I do that, we should have something that looks like, whoops. Now I don't need to translate to the middle. PZCam does that for me automatically. And it shows something that looks like this. And we can rotate around. And we can see this is indeed something very spherical. I can look at it and rotate around. And we can really see also, by the way, how this total value is going to affect the resolution of this sphere. So for example, if I were to say I just want to use 20 units for each latitude and longitude, whoops, run this code, you can see that sphere is still there, but you can see there's not as many. Oh boy, this is very hard for you to see. Just for the sake of the live stream, let me say stroke weight 4 right now, so that those kind of dots become, oh, and I should probably start further away. You can see the kind of resolution of this sphere as much smaller, so to speak. Okay, yes, so Oliver's pointing something in the chat that it should be less than or equal to total. I'm going to get to that in a moment. I'm going to get to that in a moment. So that's going to come up as I start to add the triangle strips. So let me leave this at 20 for right now. And let me just fix this PZCam thing to start a little further away. OK, so this is real. This is what I'm looking for. I now have a sphere. Now, here's the thing. The sphere now is just dots. And what I want to actually do, come back here, is to have each one of these dots become 2 triangular polygons. You know, there's a variety of ways I could kind of mesh this sphere, but this is an easy way. And so what I want to do is create these triangle strips. And I'm going to create them as horizontal strips. So I want to, for each time I go to a different latitude, I want to start a new triangle strip. And I need to say each triangle is 1 longitude value, followed by another longitude value, followed by a value that follows, no, I think what I'm going to do is this. Yeah. So I need to say 1 longitude value, followed by the latitude below it, followed by another longitude value there. And that gives me that. And then when I go down here, it'll give me this. And when I go there, it'll give me this. And when I go down here, it'll give me this. So that's going to connect that whole wraparound as a bunch of triangles. I don't know if I explained that so well, but let me know in the chat. OK, or the comments, or whatever, wherever this video is being watched. OK, so first thing I want to look at is, in order to do this, what I actually want to do, I think will make things simpler, is calculate all of those vertex points in an array, because I want to pre-compute the sphere and then draw it in a separate loop, so that because I'm going to be using different points along the sphere as I go. So one way of doing that is to create a 2-dimensional array. So and the idea here is that I have a 2-dimensional array to store the x, y, z value for every single latitude and longitude. So I'm going to come back over here, and I'm going to say p vector 2-dimensional array. And I don't know what to call it. I'm going to call this globe. And then right somewhere here, I could be smart about this. Let me be smart about this. And very little that I do is smart. I'm going to put the total as a global variable, because what I'm going to do here is say globe is a new 2-dimensional array. And what I need, which has total and total. So I need 20 columns and 20 rows, essentially. 20 spots for latitude values and 20 spots for longitude values, whatever. There's probably a science to this that often escapes me. But OK, so I'm doing that. And then here, instead of actually drawing the points, I don't want to do that anymore. What I want to do is say globe, I is longitude. So I'm going to say, so actually, I want to do this differently. I want to do, for every latitude, do all the longitude. So I'm actually going to change this. And I'm going to have I refer to latitude. So I want to swap these. I think I'm doing this right. We'll find out. So I want to say I is like the longitude value, j is the latitude value, is a new p vector. A vector, by the way, is a data structure that can store the x, y, and z components all together. There's more to it than that. I have plenty of other videos about p vector. So I want to do this. Let me just run this, make sure I don't have any errors. Great. So now I'm going to copy this loop exactly. And I don't need to do any of the calculation anymore the second time around. All I need to do is say, I have a p vector v, which is at that spot. And then what I want to do is draw the point. So I just want to make sure the same thing works. v.x, v.y, and v.z. So I should get the same exact thing I had before, which it looks like I do. So I haven't done anything new. The only thing I've changed is that I first have a loop to calculate everything, because all the sine and cosine stuff is expensive calculations. So I don't want to do that multiple times if I don't have to. So I'm going to calculate everything, put it in this two-dimensional array, and then use the two-dimensional array to set a bunch of points. And now is the moment where, instead of points, I can say, for every j, I want to start a new triangle strip. And at the end of every row, or every kind of every latitude, I want an N shape. And I want the vertices, I want to set the vertices to be this vector. Now, however, I'm going to make this v1, because remember what I needed to do was I needed to say I want to set this point, then this point, then this point. And that gives me a triangle. Then this point, then this point. So I need to skip down one. So what I'm going to do now is say I want another vector, v2 equals globe I plus 1j. And then I want that to be the next vertex. Just by the way, let me just comment this out and show you what happens. I don't know if we're going to get anything at all. We get just these like lines across. It didn't actually make the triangles. And I think we can do away with the stroke weight. I'll leave it at 2 just so it's quite visible. So you can see what we've got here. We've got this sort of almost like, I don't know what to call that, like foldy, patterny thingy. So I need that bottom vertex. I need to do top, bottom, across, bottom, across, bottom, across. And now once I do that, you're going to see, okay, I have an error. I have an array index out of bounds error. Why? Well, I'm only going from j to total, and then I'm saying I plus 1. So I could say, just for right now, I'm going to say total minus 1. I mean for I. Total minus 1. Like because I need I in the next one, I want to stop 1 early. And now you can see I have the triangle. I have that triangle stripped. Now let's look at what's going on here. There's like this hole. There's like a seam here, and also, I didn't finish the top, I think, is missing. Maybe I kind of got it. There's like a bunch of holes. So why is that? Well, there's kind of a problem, which is that while I'm going around while I'm going around, I mean, it's kind of nice looking, and it's interesting to see how you could manipulate and cut holes and do all sorts of things. But while I'm going around it, I actually need to end up where I started instead of stopping at the last one before. And so we need to adjust the code to really do that. And one way I'm going to do that, it was a trick way, is just say like, well, I have this value called total, which is 20, but I'm actually going to make my array always 1 bigger. And then I'm going to do less than or equal in the loop. Or I could just do less than. You know what? Just for consistency, this is really the same thing. I'm going to say total plus 1. Total plus 1. And then now with I doesn't go to total minus 1 here. I goes all the way to total, and j goes to total plus 1. So if I run this again, we should see here that I have the whole sphere now. So you can see I have now created geometry for an entire sphere. And there's all sorts of exciting things we could do all of a sudden now that we've done this. All right, hold on, time out. Let's keep going. Yes, we're sort of programming the Death Star in a way. Now, let's do a few things. I didn't notice. I had a fill here. I didn't realize that. So let's do something. Let's just say for a second that I want to look at, I want to just sort of see these as separate strips. So what I'm going to do is I'm going to say, I'm going to have a different fill here. I'm going to say, if I modulus 2 equals 0, what does that mean? I modulus 2 equals 0. Modulus is an operation that gives you the remainder of division. So 2 modulus 2 is 0. 3 modulus 2 is 1. 4 modulus 2 is 0. 5 modulus 2 is 1. So I'm saying every other kind of row, so to speak, let's say fill 0. Otherwise, fill 255. And now we can see really that we have these strips here. So I have each, and I did it? Wait. Let's start over. Did I really do this? I think I did something backwards because I was imagining my strips going across this way. So I will look at this. It doesn't really matter. Yeah, so somebody in the chat points out that I shouldn't be recomputing the sphere over and over again in draw, and that's absolutely true. The only reason I'm doing that is because ultimately I'm going to animate and I'm going to morph the sphere, and so at that point I'm going to need to recalculate the points every time, so I'm setting up the examples that way. Okay, so you can see how I can kind of alternate colors. I could also do something like, let's make a rainbow. So I'm going to make HSB color as the color mode, and I'm going to fill from, I'm going to say, give me a hue value, which is maps I guess I can do this with J now if I want, which maps J, let's just try that, from 0 to total to 0 to 255, and I can say fill that hue with full brightness and saturation, and now we have got a kind of rainbowy looking thing, but you can see like first of all, let's take out the stroke. Let's take out the stroke just so we've got the colors. And I'm going to say no stroke. And I'm also going to do something like, well, let's actually map the hue to 255 times 6 and say hue modulus 255. So we cycle around the rainbow multiple times. And there we go. And I didn't get this, so I messed up having this line up, the seams line up correctly. I'm going to fix that in between this video and the next one. I'm not going to, you could fix that on your own as an exercise. I think I have a couple things backwards here and there as I built this. But you can see what the possibilities are. I could also start doing things like, I could take these, each time I calculate the globe, I could also say, I can make a random vector, a random 3D vector, random 3D. I could scale it by some amount, 10, and then I could say globe I j dot add that random vector. And if I do that, you're going to see I now have this sort of like jiggling. All the points are kind of moving randomly. I could do something with Perlin noise. You can see the possibilities emerging in how you individually color each tile and how you might individually move and adjust those points. So this, I think, finishes my tutorial on sphere geometry. And what I'm going to do in the next video is fix a few things here that I might have gotten wrong, as well as move towards how I can turn that sphere into generating these super shapes. So right now I moved these points around with random numbers. What kind of other math might I apply to start moving the points around and seeing how that's done? So thanks for watching this sphere geometry video. Stay tuned also for, I'm going to look at how to maybe do this with WebGL in JavaScript in a separate video. So I've also got that coming as well. Okay, see you soon. Okay. So I'm interested in where, I'm going to take a moment to pause here, and I want to look at what I sort of did wrong here. So let me go back. Let me get rid of this random thing. So first let me save this. Let me get rid of this random thing. I don't want to add this. And then what I want to do is put this back. Let me think over here. I said that these are latitudes. So for every, I want to move along, oh no, I was right. I want to move along the longitudes. The longitude should be the outer loop. So I just did this wrong because my head was on backwards. I got it close enough. So I want the longitudes to be the outer loop. And then what I want to do is if j mod 2 equals, oh no, I can still have I. Oh, okay, hold on. Oh! And then I changed it down here. I should do some tau thing, right? I always forget about tau. I'm kind of like have a mental block when it comes to tau. Okay, hold on. Let me just fix this. So what I want here is I want to have latitude, I want to have longitude in the outer loop. because I want to be changing. No. Okay, hold on. I'm really losing my mind here. Let me look at this again. Why does this make my head hurt so much? I need to just go back to the music thing. Okay, what I want to do, this is the triangle strip I want to draw. So I'm starting with this point and then moving to this point. And those are different, I'm incrementing longitudes. I is incrementing longitudes, and then I want to go, and the thing that I'm skipping down is latitude. So that's right. So I should have longitudes be the inner loop, because I'm moving along different longitudes. Latitude be the outer loop. Okay. Longitude should be the inner loop. Latitude should be the outer loop. And this is what I did, though. Okay. And then I is mapped to latitude. Okay, hold on. And then J is going up. How come that didn't work? Whoops, what did I get wrong here? Oh, less than or equal. Oh, my longitude and latitude are wrong in the sine and cosine. Oh, that's got to be it, right? Oh, no, whoops. Yeah, that's got to be it. That makes sense. Oh, it's totally wrong. Why did I do that? No. There are 101 people watching? That's crazy. Okay, so hold on. Oh, I'm doing this wrong here. Ah, no wonder. Wait. I want a new hue for each. There we go. For each. Yeah. Well, I kind of like that, actually. So why did that not... I got to update those neural network chapters, yeah. Okay, well, this looks nice. But why is it not doing what I expect? Okay, so let's think about this. Okay, so I am saying first, the hue is... but the hue should be mapped to J. That's what I did. I should pick an I should use X and Y, because instead of I and J, that would make me... It is wrong. It's wrong, but you change the loops around. It is wrong? Okay, let me look at the Wikipedia page. Oh, yes, it's totally wrong. This is not... This is latitude, and that's longitude. Yes, it's totally wrong. Interesting. All right, what did I miss now? Just like messing around here for no reason. Okay, wait, hold on. What did I get wrong? This is very sad to me when this happens. What time is it, by the way? 1:50. All right, it's only been an hour. Okay, let's see. Please, if you're watching this in the archive, skip ahead somewhere. At some point, I can't see the future, but I hope the future this is fixed. I got to turn this fan on a little bit higher. It's very hot in here. Latitude is 0 to pi, not negative half pi to half pi. Really? makes sense. There we go. All right. Yeah. Okay, so this is right. Oh, well, my tutorial had some flaws in it. I'm going to save this as correct now. Oh, and I didn't even show the whole detail thing. Ah, I should make a little addendum. Just to, you know what? Maybe I should add a little addendum now onto that previous video to correct those things. Why did I say? Oh, you know what I'm using is. I'll just do this too. Yeah, I should just do it this way also. 0 to pi and 0 to 2 pi. Maybe that's better. Okay. All right. So here it is. It's working. Sorry. Now, let me see if I should. Nah, I'll just leave it in the next video. I got a few things wrong slightly. The code, when people go look at the code, it'll be correct. Now what I want to do, just by the way, I want to look at this. If I say like 200, for example, you can see now I have something like this. This is a very nice rainbow sphere. Yes, I know tau. Let's all have a tau moment. Tau is the 19th letter of the Greek alphabet. In mathematics, an alternate circle constant to pi, you know, I could use tau. I don't want to get into the whole tau thing. I think there is, yes, I know the fan makes some noise, but I will turn it off in a second when I go do the Supershape thing. Is there a tau constant in processing? I believe there is. Yeah, looks like there is. Because it changed the color. Let's look at both these values. And you can see there, you know, it's like basically 2 pi tau. Okay, but I'm just going to keep with 2 pi. Shoot. I wish I hadn't gotten this wrong when I made that video. I'm trying to decide if I should record the addendum. I think I will. Okay, so what I'm going to do right now, and Mathieu, who graciously helps me edit these things together, is rather than put these fixes in the next video, I'm actually just going to record I'm recording everything right now, but I'm just going to do a 30-second thing where I make the point that I mixed up latitude and longitude in those formulas. And then I also changed my ranges from instead of negative pi to pi and negative pi over 2 to pi over 2 to those ranges. Okay. Can you say for me, nice job, excellent, great, and game over? I guess I just did. Nice job, excellent, great, game over. Okay, go for it, addendum. Okay, Mathieu is in the chat and is saying to do it, so I will. Okay, I'm going to turn the fan. First of all, can you hear my strange voice? I'm going to turn the fan. Oh, I turned it off, which I did not want to do. I'm looking forward to the fall when it's cold again. Oh, I got a little lightheaded. I'm standing up too fast. Okay. Cycle the camera. Okay, oh, I also have to tie my shoe. I'm not wearing my daughter bought me some rainbow socks. She didn't buy it for me. She was only 4. But she suggested I get some, pick them out. But I'm not wearing them today. I think I said this the last time I was on the live stream. Okay. Okay, here we go. Addendum time. Epilogue. Okay. Hello, epilogue to my Spherical Geometry video. I unfortunately had a kind of fatal flaw in my code, which I didn't notice. It was pointed out to me in the chat. Thank you very much, internet. And if you'll notice here on the, timeout, stop. Okay, I'm going to redo that. I wasn't on the right page. I want the Wikipedia. Where did that page go? Wikipedia Wait, hold on. Spherical coordinates is what I'm looking for. Let's look at the Math World page, by the way. Ooh, never look at the Math World page. Yeah, let's look at the Wikipedia page. Supershape rainbow socks. Yeah, I gotta make some like t-shirts and stuff. Everybody wants that stuff. Okay. Yeah. Okay, spherical coordinates. Here we go. Okay. I'm looking at my text messages. I can't answer those right now. Grocery list requests. I don't know why I'm looking at that now. Yes, baking powder. Internet. Someone, I need baking powder. Okay. Here we go. Why do I look at my, it's so ridiculous. But anyway, okay. It's like impossible. Did you know that I read a recent study that if you're having a conversation with somebody and your phone is just on the table like in the peripheral vision, it's off even, it's just physically there, it takes away from the sort of intimacy of the conversation. You really ought to think twice about the kind of ways that we're interacting with people these days. I, for one, welcome all of you with a hug, if I could. Okay, here we go. Hello, quick epilogue addendum to that video. There was actually a big fatal flaw. Not so fatal, actually. My code was fine. It made something interesting. But there was a flaw where I wasn't getting the effect that I expected. The effect that I expected, let me run this now, is this, which is actually getting nice, perfect horizontal bands of color for the rainbow effect. And the reason why is I had in these formulas by accident reversed my latitude and longitude. And we can see on the Wikipedia page that right here, this theta actually refers to latitude, having a range between 0 and pi, and phi, phi, fo, fum, the Greek letter phi, has a range, refers to longitude, or the range between 0 and 2 pi. And I don't know why I had between negative pi and pi and negative pi divided by 2. I now also adjusted those ranges, and you can see the ranges are now between 0 and pi, 0 and 2 pi, and have latitude and longitude in the right place. And we can really see, and this, by the way, I have also changed the sphere detail to 200, the total value to 200. So you can see those bands are much more kind of nuanced and detailed. If I change this back to something crazy like 5, you would see that like now this sphere has very sort of like strong, hard geometry to it. And it would be interesting to kind of make that a dynamic value so you can kind of have this, you know, almost like cube morph into a sphere. So I'll let you play around. The correct code will be posted. Hopefully you weren't like typing all these comments in the chat to fix it and then you got to the end of the video and realized I fixed it at the end. But if you did, then that just means you're kind of participating in the community that is this world, and that makes me happy. So thanks for watching this addendum, and who knows? There might actually be another addendum starting a moment later, but I don't think so. I think this is the last one. Goodbye. Okay. It is not offensive, and I love Rick Moranis. I'm a huge Rick Moranis fan, but I'm not the son of Rick Moranis. I don't believe I'm even related. Okay. Okay, so now, I think we are done with the sphere. So I need to go to the Supershape. I like it. This is good. Okay, so I'm going to save this as code, and I'm going to go to Sphere, and now I'm going to go to Supershape 3D. Do I already have something called that? Can I replace it? Yes. Oh, you know what? Let's do something. Before we do this Supershape, maybe I should, let's see, time-wise, it is 2 o'clock. So I'm trying to decide whether I should attempt to, I'm looking at the chat here. I'm trying to decide whether I should attempt to see if I can make this same code work in P5.js or move on to the Supershape and then come back. Let me do the P5.js after the Supershape to make sure that gets done. Because I could always just, I don't necessarily need to make a video of that, so let me do the Supershape. Okay. Oh yes, and I need to reference Riza Ali's work here, which I did at the beginning of that video, but that's fine because that was really just about the sphere. Because I want to say that I have not used any code for making this from Riza Ali. I don't know if his project is open source or not, but I have taken a lot of inspiration in terms of looking at this to figure out how to make this work. Essentially, I'm duplicating this project as an example. So thank you, Riza, for your support and for your great work. So what I'm going to do is just keep this open. Is there, I'm trying to decide if this is the page. I think this is the page I should reference. Okay. And is there another sketch open? Yes, Supershape. Now the other thing I need to look into is why. So in this, the reason why I had that in my head is I had done it this way for my Supershape examples. And I had also changed latitude, and these formulas are a little bit different. Are they? Let's look. Now, yeah, they are. So you can see these formulas are a little bit different. The question I have is why. So let's actually just go. I'm going to go to my Supershape working example, and I'm going to see like what happens if I do something like, whoops, put them back. Does it still work? It looks wrong, right? It looks different. What if I do 0 to pi and 0 to 2 pi? Yeah, this looks kind of more right. There's something weird going on with it. So the question is, that seam is not matching up now. Why is that? But if I put it back to the way I had it before, the seam does match up. So I better keep it this way. And the question I have then, Oliver had written, I'm back. Sound is working, I hope. So please let me know in the chat if that's the case. Oh, this didn't publish to Facebook. Life will go on, I think. Okay, do you see me? I don't see the stream live in YouTube. Oh, I do see it now. Okay. Hold on. Hold on. Trying to get this going again. Please tell me in the chat if you can see and hear me. Refresh the page. If you can't hear me, I can't tell you to refresh the page. Okay. Hello again. Welcome to
Cutting Rainbow.
Cutting Rainbow.
With me.
Cutting Power.
Okay, so I'm back. I'm just trying to make sure everything is working. Prasenjit asked in the chat, how can I see the first part of this? So everything that happens today, this first part and second part, will be put together in a single video that will appear on YouTube some point today or tomorrow. If you subscribe to my channel, you'll get a notification. And then, of course, actually I'm curious. This is not really a good forum for me to just hear everybody's opinion about this. But, you know, originally, let me just take a short break here before I go do the Supershape to talk about something sort of random, which is that originally I was doing these like sessions. They were not broadcast live. I would just like, have the cameras on, I'd kind of like do some stuff, and then I would stop and say, hello and welcome to a tutorial about hue, saturation, and brightness, blah, 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 thank you. And then I would finish, and I would make these video tutorials, and then I would upload them. And then at one point, I was like, oh, maybe I could just live stream my recording session. But now, so anyway, I'm a little confused if it makes sense. I think what I'm doing makes sense, which is to keep these kind of raw, unfiltered live things and then have separate standalone videos for people who want to kind of just like get the actual tutorial chunks. Anyway, I think I talked myself into what I'm doing makes sense. But if you have any feedback of different ways to organize this, I'm very interested. Okay. Also, it's been asked, how much longer will you be streaming? I had hoped to finish around 3, which is 45 minutes from now. I think that I could reasonably do the Supershape thing in that time. I wanted to also sort of check and see if I could kind of quickly port the code to P5.js. So we'll see, the most, I would say by 3, that was the first half was like a little over an hour. I tend to run out of steam after 2 hours, to be honest. Although I did do one live stream, which is 3 hours and 48 minutes. I don't understand how I did that. And I do have this idea of at some point doing like an all-day marathon, which I think would be fun. Maybe I'll do that for, by the way, the 50th episode of... So anyway, by the way, if you're curious, I know I'm rambling now, but so if you go to YouTube/Schiffman, I think it's kind of interesting if you go to this playlist, Coding Rainbow Live, that probably doesn't show up to you like this. You can go back and watch the very first live session I did, which, oh look, and I can't believe now I'm making you watch an ad, which is sort of horrifying, skip ad. There's a lot of this, because I didn't have 2 separate computers, so there was a lot of me, I have a giant head, don't eat me, I'm being eaten by my giant head. There's a lot of this because I didn't have 2 separate computers and I was trying to like figure things out. And you can watch that if you want. Okay, close that. All right. So that's the thing. Now my pants are falling down. I'm fixing my belt, and I think I'm ready here for Supershape time. So I think what I'm going to do is open up this page. And I kind of want to have a sense of why these formulas are slightly different and why these ranges are different, but I'm just going to skip that right now. So I need this page open. I need this page open. I think this might be. This could be good to have. And this page, I don't, yeah, that's fine. Okay, and now I want this open and this open. Okay, so this, okay, so I think I am ready now. We should do some thumbnails. I don't know what's a good thumbnail. I kind of like the ones that look like this. Okay. So what was I saying? Okay. So I think I'm ready to do the next phase. The next phase is to take the sphere and turn it into the Supershape, and then show you how to animate the Supershape, morph between 2 different Supershapes. Ooh, I don't think I'm going to get to that today. And I think that's my next phase. Okay, so I need to show this. I want to reference Riza Ali. I believe I'm pronouncing Riza's name correctly. And then I will show the Paul Bork site, and then I will go into the code and start adding those other math formula. It's as easy as that, I think. Okay, I'm pacing. I feel nervous about this one. Let me cycle the cameras. Hopefully the audio glitch won't happen. If you're wondering why, usually during these live streams I complain about being hungry, but I ate a big, nice, healthy meal at around 10:30, sort of anticipating I was going to get started, and so I'm good to go for a little while longer. Okay, I know that's what's on all of your minds. Okay, just in case. I have a theme song. The first version of the theme song has been written. I have heard it. And the Coding Rainbow theme song music video is coming. So you can all remix, make your own with the green screen stuff. Oh, the sound is gone. Oh, sorry. I don't know why I'm doing this right now because it doesn't really matter. Yeah, okay. So now the sound should be back in this shot, right? Rainbow. Okay. All right, let's get started here. Okay. Okay. Hello and welcome to the final timeout. Start over. Hello and welcome to the Supershape Coding Challenge Grand Finale. In the previous video, if you watched it, you didn't have to have watched it to follow this one, but if you watched it, I figured out how to make a sphere by iterating over latitude and longitudes and calculating spherical coordinates and creating a lot of triangle strips and coloring them like so. And you see that on your right, that pure, nice sphere with horizontal bands. And what I want to do in this video is show you how to take that sphere and turn it into this crazy looking supershape. Now this is just one example of a supershape. What are supershapes and where do they come from? So first of all, I want to reference you the work of Riza Ali. A link to his work will be in the description of this video. He has a wonderful art project all about supershapes that you can look at and enjoy, and some videos you can watch, beautiful ways of coloring and messing with them. This is really where I took my visual inspiration from, this particular work. Where I've got the math formula from is from Paul Bork's website. So what's going to happen, what we're going to do is, instead of simply saying something like, right, in this sphere that I've calculated, the point for the sort of x, y, z point for every single latitude and longitude, there is a radius, a sort of fixed radius of 200. So what if we had a kind of crazy way to calculate the radii? So for example, if we just use Perlin noise or a sine wave, we might see some rippling-like looking sphere. Well, it turns out this strange formula, for whatever reason, when you take either the latitude or longitude angle and calculate a radius based on this crazy formula, you get all sorts of values and you get these supershapes. And if I scroll down, we can see there's a whole bunch of kind of constants here. There's n2, there's actually there's a constant m, there's actually 4. There's m, n1, n2, and n3. And if we scroll down here, you can see based on how you might set those values, those constants, you'll get different shapes. And this is actually the one that you're seeing in the particular example that I showed you. And you can see all sorts of various possibilities here. So the goal here is I'm going to make you, I'm making you, I don't know what that means. I am going to right now take that sphere and add those math formulas so that we can see these super shapes on the screen. I'm just going to scratch the surface on this. And it's my hope and my goal that you take this and do something creative and interesting with it, and I'll talk about what the possibilities might be at the end of this video. Okay, so let's just get started and think about some things we need to add and change to this. So I'm going to close, move around here for a second. I'm going to close this. And so this is the code that I right now have to work with. It uses just plain old spherical coordinates. So r is a fixed value of 200, and I get the x, y, z value, and then I draw and set the sphere. Now, what I'm going to do just briefly is kind of take color out of this for a second, because I think that'll help us kind of debug this a little bit. And I'm going to say stroke 255, no fill. And so there we can see, again, this is actually what's being drawn. This is just the kind of wire mesh of that sphere. And I'm also going to change this variable total up here to 25, just to make it a little less detailed, so we can kind of might help us sort of see what's going on. Okay, so now that we're there, what do I need to change? And let me just give myself more space here. move some things around. What I need to do is simply change the math that's going on here. Instead of the pure spherical coordinates, where I just go from the latitude and longitude to a single radius, I want to have different radii values based on the latitude and longitude. So let's look at how that works. Once again, here is this formula. Now, I think what would be really useful would for me to have a kind of like visual reference of this formula always on the page while we're programming this. And I also am going to need this. So I'm taking some screenshots here. I should have done this in advance, but I'm just doing this in my video. I'm going to open these up with Mac Preview and put these up here in the corner. So as I'm writing the processing code, I can kind of have a reference to this. OK. So, and actually, you know what might be useful? Let's make a function. Let's just say there's a function called Supershape. And that function returns a radius value. And it returns a radius value, I'm going to say, based on what? Based on some amount of constants. So I need I need m, I need n1, I need n2, and I need n3. So the idea here is that what I could do here is say R1 equals supershape based on some constants. Like, oh, did I call it super? That would be a supershape. Supershape based on some constants. Like the one that I'm going to do, I happen to have some constants memorized. I don't have them memorized. I'm going to go back to Paul Bork, and I want to look at let's start with this one. So I want these particular constants, 0.2, 1.7, 7.2, 1.7, and 1.7. So I'm going to do 0.2, oh, sorry, 7, 0.2, 1.7, 1.7. And then actually what I need to do, one thing you'll notice about this supershape is that the spherical coordinates have been adjusted slightly, the way that this math works. And so I'm going to make those changes as well. So I'm going to change this to, I'm going to change this to cosine, cosine. I'm going to change this to sine, cosine. And I'm going to change this to sine. And then I also need to have these new values, R1 and R2. So I'm going to say times R1 times R2 times R1 times R2. And I'll talk about what these are in a second. I'm just adding them into my code. And then also R2 times R2. So why are there two values? Well, pause. I lost my train of thought. Hold on. This is getting very hot in here, and my mind started to melt. So let me think about how to phrase this, and you guys can help me in the chat. So the reason why there are two values is because ultimately we're kind of, what's kind of happening is, okay, if you think what a 3D supershape is it's kind of like taking two of those 2D supershapes, one that's flat, kind of like you're cutting in the center, and one that's vertical. So like if you have, I should have brought an orange so I could like make. All right, I think I am back again. Refresh the page. Back, I'll type in refresh page. OK. You change all the sines and cosines incorrectly. The equation has latitude in all the rightmost equations, but you don't. Oh, yes. Thank you. I guess let me fix that. OK. OK, I'm back. Yes? Do you guys hear me? Sound is OK. I have to refresh to see. OK. So I'm back. I forgot where I left off, but I think I like lost my train of thought, and I was trying to explain why there's an R1 and R2. And I think what I'm going to say is that, and this is kind of like a loose approximation that might not be exactly right, but if you think back to my 2D Supershape tutorial, what the 3D Supershape is really like having two flat ones kind of rotated with rotated around each other. So that's kind of what I'm going to say. Does that seem about like anybody who knows anything think that that's not like the worst way of saying it? I think that's kind of, and then I have a mistake here that I have to fix, and I'm going to keep going. Okay, I gotta move along here. Hopefully that audio is not going to go out in the fritz again. Okay. Back after an audio glitch. So what I was talking about was why is there an R1 and an R2? Well, what this 3D Supershape actually is you can think about, if you remember, there is actually a previous video where I look at just a 2D Supershape. And what the 3D Supershape is, it's kind of like having a 2D Supershape flat like this and a 2D Supershape flat like this, and then rotated around each other. So in that sense, there's a radius that's determining, there's kind of a radius calculation for the one of those Supershapes and a radius calculation for the other Supershape. And those Supershapes are calculated based on latitude and longitude. So what I need to do is calculate both an R1 that's based on, right now they're going to be the same, so I don't know if it actually matters. I need an R1 and I need an R2. So this is the idea, that I want an R1, which is Supershape. And by the way, I forgot the most important parameter to this function, which is that I need to pass in that angle, latitude, and I need to pass in that angle, longitude. So I'm going to go back here, and I'm going to add the first argument as theta. So first thing I'm going to do is let's just see, whoops. And I lost my latitude, longitude. Oh, no, it's here. This has to go above. So there's a lot going on here on the screen here. But let me just take a moment to take a deep breath and look at it. So what I'm doing is I'm looking the same thing I did with the sphere. I'm saying for every latitude and for every longitude. Let's calculate a Supershape radius value based on the latitude, a Supershape radius value based on the longitude, and then apply those formulas. I actually have a mistake in those formulas that I can see now, which is that cosine longitude, and this is latitude, latitude. And then there's something else here, which is that for the calculations to work correctly, I want to have my latitude range, instead of going from 0 to pi, to go from negative pi over 2 to pi over 2, and longitude range as well. So I'm going to change those ranges to go from negative half pi to half pi, and then negative pi to pi. Now, one thing you'll notice is that this value r is not present here in this particular formula. What I'm going to do is calculate kind of a unit Supershape that's based on the value of a range between 0 and 1, and I'm going to use that value r to expand its size. So I'm going to keep that as 200. And so let's just see if I run this. Right now the Supershape function is just returning 1 no matter what, so I'm not actually doing the calculation. And if I run it, you should see I've basically still got that sphere. So I'm still getting the sphere. If the Supershape calculation just returns 1 for R1 and R2 for every single value, I'm still going to have that sphere. So now it's up to us to put the math here correctly and not have things go too terribly awry. So let's give that a try. I've got R1 and R2 the wrong way around. So, so let me correct that, meaning that R1 should be based on a longitude like this, and R2 should be based on latitude like that. Let's see. So maybe that's the way. I guess I could look at the formula, maybe edit this out, and see that, right, R1, oh yeah, R1 of theta, so R1 of longitude. So R1 is based on longitude. Yeah, so I should have just looked at this, by the way. You can see that this formula is saying calculate R1 value based on the longitude and an R2 value based on R1 value, yes, based on the longitude and R2 value based on the latitude. Okay, so that should work. Okay, got it. I fixed it. Hopefully that's right. Let's still look at the result, and we should still have that sphere. I just had them backwards. Now, okay, let's come back here, and now we're going to start to put in that math. Oh boy, oh dear. So I'm going to give myself some nice room on the screen. I'm going to move this down and then move this over here so we can see that formula. So what are some things I need to calculate? Oh, and I forgot, there's A and B are constants too. I'm just going to, for now, A and B are going to change sort of the quality of the shape in the sense that it's going to like stretch it or smush it on a horizontal or vertical axis. I'm going to leave those as 1 right now just for simplicity. And let's first calculate this particular value. So I'm going to say T1 equals 1 divided by A times cosine of m times theta divided by 4. And what do I want? I want the absolute value of that. And then I want to take T1 and set it equal to itself to the n2's power. So that's giving me just this component right here. I'm doing this particular math and setting that to the n2th power. Then let's do T2, which is the absolute value of 1 divided by b times sine times n times theta divided by 4. And I'm going to say T2 is itself to the n3 power. Then what I want to do is say T3, and I'm just using T as some arbitrary like variable naming structure. I want to just calculate the parts of these. I need to add T1 and T2 together, T1 plus T2. And then I need to take that and say T3, take it to the power of -1 divided by n1. So then that's really what R is. So that's the end, right? Oh, no. Yes, the whole thing should be then float R equals the result of that, and I should be able to return R. So let's now, I don't know if I'm sure I made a mistake. Oh, somebody in the chat, A divided by B should be 1 divided by B. Oh yes, this should be 1 divided by B, thank you. I don't know if I have any other mistakes here in the math, but let's run this. Oh, I'm getting an error. I have some parentheses out of place. So absolute value of, there should be another parentheses here. And let's see what I get here. Miracle of miracles, that looks like that particular supershape. So we can see, let's have a look, right? It should look like this one. I am doing these values, I should get that. We can see that's what it looks like. A couple things just to be sure. I can give myself a little bit of a higher resolution by having 75 points for every latitude and longitude. I can also, what I can do is I can put the, well, let's run this again. Now you can see the resolution is finer. This looks pretty good. I am going to now give it just like a fill of white. Oh, and it says no fill right after that. So we can sort of see what that looks like. Okay, that looks still pretty good. I think we've got it. Okay, missing a bracket. I don't know. Somewhere I'm missing a bracket, but it looks right. Maybe that comment is in the past. Okay, so let's see if we can get one of the other super shapes to look right, and then we'll start messing with the color and maybe do some animation. Okay, so what I am going to do now is let's go back to Paul Bork, and let's pick another one. I don't know, what looks like a nice looking one? Let's try this one. And so what you're going to notice is that there are now different values for Supershape 1 and 2. That means different values for R1 and R2, right? This two-dimensional supershape that's kind of all along the longitude, the two-dimensional supershape that's along the latitude, and they're rotated against each other. So what I'm going to do now is say, can we remember this? 8, 60, 130, 8, 60, 130. So I'm going to go here and say 8. Well, that's R2. I don't know if that it really matters. So let's do 8, 60, 100, 30. Now we're going to go back and say 2, 10, 10, 10, 2, 10, 10, 10. The Supershape song. 2, 10, 10, 10, 2, 10, 10, 10. So now I'm going to go up here and say 2, 10, 10, 10. Okay. Does this look, that looks kind of like what was in there, right? I can zoom out a little bit to see. I think that looks like that shape. So let's go back and see. Yeah, that looks right. So I think all of our formulas are looking correct. We can say I can put this at this angle. You can see those match up pretty well. We can actually go back and add that color stuff that I had before from the sphere, right? I can get rid of the stroke. And I can add hue. And I can have the hue kind of cycle. And we can see now I've made this rainbow super shape. And I can zoom out. So we're really moving along here. So you now can take this code and you can plug in the different values, see what shapes you can get. You can try different colors. You can try to make vertical stripes or horizontal stripes or have it animate. This would be nice to do actually really, really quickly. I could just add a variable like offset equals 0. And I'm going to, in the hue, I'm going to say hue plus offset mod 255, and I'll just say offset plus equals 5. I don't know what this is going to do, but you can see now I have my like cycling colors, and I want to like zoom in here, and then we can have this beautiful, why is it so, it looks kind of dark all of a sudden, but I have to stand in the middle of this. Whoa, okay. Oh wait, I'm actually recording a tutorial video, I forgot, not just like messing around. Okay, so you can see there's like lots of kind of crazy, oh, because the lights are over here. There we go, this is brighter now. Whoa, okay, I'm gonna make myself seasick. Okay, so you can see that there's all sorts of possibilities of things you can do. I wanna do one last thing in this video before I stop and give you some thoughts about other things you can do. Let's at least make it animate a little bit. So I wanna go back, I'm gonna comment, and I think, first of all, I think it could be a lot more thoughtful in terms of how you store these things as variables. I'm just kind of doing it haphazardly right now. But I'm going to go back to that, the first super shape, which has sort of equal values here. And it was 7.2, 1.7, 1.7. Did I get that right? Is that what it was? Let's see. Yeah, so you can see now here's this particular super shape that I started with. So what I want to do with this is now just show you how to animate it a little bit. So one thing I could actually do is just say, let me make this m a global variable. So I'm going to call this m, and I'm going to have a global variable called m and have that equal to 0. Now let me just run this right now and see what we get. With an m of 0, you can see this is actually just back to that sphere again, interestingly enough, because it kind of like cancels out, multiplying by 0 cancels out everything. So what I can now do is I could say something like m equals map mouse x, which goes from 0 to width between 0 and 7. So now as I start the sketch, you know, you can sort of see as I move the mouse around, it kind of morphs from that sphere all the way to that particular shape. And I could say, well, let me have some kind of global variable like angle. Well, I already have an angle variable like, let's just call this like m change. I don't know. I could probably think of something better. But I'm going to have a variable called m change and have that equal to 0. And what I'm going to do is I'm going to actually map sine of m change, which is like a nice smooth oscillation, which goes between negative and 1 to between 0 and 7. And I'll have m change, you know, change over time by some value. And then what I've got is this thing kind of like oscillating back and forth, almost like this weird super shaped breathing thing. I don't know why it's brighter on one side the way that I have the light set up. So it's, you know, breathe. The camera's going to go off because I've hit 30 minutes. So, so you can see kind of what's going on here. There are a lot of possibilities. Now, the other thing that I would say is sort of interesting to think about is not just morphing from kind of 0, but what if you took two different super shapes and had those values interpolate between one to the other? So you actually morph one to the other. That would be a great exercise for you to try. I think I've pretty much reached the end. The stream went offline. Okay, sorry, but hopefully this is recording anyway. So hopefully, I think I've reached the end of this particular tutorial. I hope that you try making some of the other super shapes, try playing with the variables and colors, see what kind of interface you could build for this. I am going to try to make a JavaScript WebGL version of this, in which case it might be easier to have an interface that controls these shapes. And so stay tuned. I'll either just post that code in the description of this video, or you'll see another video kind of converting this code to JavaScript. Thanks for watching the Supershape tutorial, and I'm sure you're going to have questions and comments and thoughts, so please let me know in the variety of channels that exist to you to communicate with me, perhaps. Okay, for real. I mean, not perhaps. Whatever. Okay, no, bye. Enjoy the Supershape. Oh, thumbnail. Or GIF. Okay, hold on. Wait. I'm losing my mind here. Oh, because my zooming, I forgot like how to zoom on the, so weird. I'm still recording a video. No, that video ended, right? Fade out. Maybe that video can fade out. I lost my mind here. Why can I got confused. You know what? I lost my marbles there. Because what happened to me is, and this camera got way out of whack. The whiteboard is showing. I don't think it's that big of a deal, but just do that. I forgot that when I want to zoom like this, I use a 2-finger scroll, and when I want to use use PiziCam to zoom, it's like a click thing. So I just like kind of lost my mind. But I was going to make I thought like I wanted to just have a good section of this video for like a GIF that'll get posted. Like, that doesn't make any sense. Oh, I do like the scrunching my head thing. I can't do it. Never mind. I'll just do this. Curtsy, is that what it's called? That'll be my gift. Okay, all right, make a creature out of it. Okay, so you guys all are having great suggestions. I don't know how I'm gonna end, I don't know, I think I didn't end that video properly, but it'll just cut out. Sorry for making you guys feel a little seasick. So it is now 10 of 3. I definitely have at least 10 minutes to hang around here. I'm just going to check to make sure there were no important, urgent messages. So I'm happy to answer questions in the chat. And what I want to do, I don't think I'm going to make this a video right now, because what I want to do is just sort of see how easily this could transfer to P5.js. So let me get that set up. This is going to be it for today. I'm going to go in the next 10, 20 minutes or so, but I will be back on Thursday. So what I want to do is I just need like any old P5. Let me just get quickly. This is what I do now these days. I'm just going to go to download just so I have the most recent. I'm going to download this. I'm going to get empty example, go in here, where, empty example. I'm going to call this a Supershape test. Okay, so I'm going to open this with the Addendum editor. Hold on, Addendum is not open. I'm sorry for torturing you with the, at least I didn't do any like horrible audio things where suddenly the sound like screeches really loud. Okay, so I'm going to close all these. Then I want to get Supershape test here in Addendum. I got to open up terminal. Maybe I will make this a video. I mean, we'll just see if it works. I can always cancel. I'll pretend it's going to be a separate video. No, not desktop. CD desktop, coding rainbow, Python-m, simple HTTP server. You guys should have some music playing for you for this. Localhost. Supershape test. Okay. Console. JavaScript console. Minimize. we're going to take this code. Well, first we're going to just make sure that create canvas, WebGL. My signature grayscale value. Okay, create canvas. Okay, so we've got the WebGL context going. Let's get these libraries in here just in case we need them. Okay. Okay, so let's see what happens. This is dangerous to do, but I'm going to do it. Where's processing? Okay, so I'm going to now, I said I wasn't going to do this, but I'm totally going to do this. And let me just fix this camera just in case. Oh no, that's just me talking. Okay. Okay, so I have a feeling. By the way, the reason why it's 51, why did I knock the camera again? The reason why it's 51 is I'm pretty sure that that's actually just sort of a grayscale value that's in a lot of the processing examples. So you should probably ask Casey Reese that question, why 51? But I trust the visual design judgment of other people way above mine. So I tend to just pull from other people who know how to make things look nice. I know I don't have PZCam and P5, and it is sort of a problem, but I can rotate without it. I'm just going to kind of not bother with it. OK, here we go. Hello, welcome to another video about Supershapes, where I am going to attempt to take this processing sketch, which renders the Supershape in 3D, and render it in the browser using P5.js and WebGL. So just to show you, I have a blank P5.js sketch set up already. It just makes a WebGL canvas and draws a background on it. That's all that it does so far. We can see those results here. And I have this processing sketch, which produces this result. So I'm actually going to do something which is probably a bad idea, which is just literally copy this entire bit of code into Addendum in JavaScript and hit save, and I'm just going to start walking through it line by line and updating every single line to be JavaScript language-like. So first of all, we have no PZCam in JavaScript right now, so I'm going to get rid of that. Globe can just be, we can just initialize it as a one-dimensional array for right now. Var instead of float for everything. Function instead of setup. Create canvas instead of size, and WebGL instead of P3D. No PZCam. Now globe, I'm going to do, actually what I'm going to do is, so making two-dimensional arrays in JavaScript is a little bit weird. I think what I'm actually going to do is just make this a one-dimensional array. Let's see how it goes with that. And so in that sense, it's going to have a certain number of spots in it, which is total plus 1 times itself. So this is some syntax for making an array with a sort of fixed length of total plus 1 times total plus 1. We'll see if that was a good idea or not later. And so I can get rid of this up here. And then I need, these are some more global variables, which I'm going to, for cleaning up, I'm going to put at the top. This is a function, and the arguments don't need a data type. So I'm going to get rid of all of those. I could use find and replace and all that, but you can fast forward this video or just stop watching it and go outside, do something else with your life. Okay, so that should be good now. This is function draw. The map function should be fine. Background stroke, lights. Let's comment out lights for a second. This now can say, these are all var, 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 var. Now here, instead of I times j, what I need to do is have an index into the array, which is I plus j times the kind of number of columns, so to speak, which is total plus 1. So this should be a nice formula for giving me an individual index into that array. So, and I'm going to need this again in a moment. And this is the same formula that's used in pixel calculations. I might refer you to my pixel video. Now I'm going to say var, var, var. Ah, this is also wrong, new p vector. In P5JS, I can actually just say create vector, which creates a vector object. And these should be good. And I need here to say this again and say globe index. And then this, and this is index 1. And then this one is going to be index 2. I plus 1 plus j times total, all of that stuff. And so now globe index 2 and end shape. Huh. Well, I forgot to change float to var in line 38, someone is telling me. Yep, thank you. So I'm just going to run. This is no way this is going to work. But OK, so line 63, I have a syntax error. Line 63, I have a syntax error. Ah, I need var here. OK, let's try it again. Cannot read apply color blend of undefined. So I've got an error here. Let's see if we can figure out where that error is. Let's get rid of the color stuff and just say stroke 255, no fill. Invalid vertex something. Oh, that's sad. OK, so there's going to be some debugging in this video now. So let's see if we can. OK, so what I had hoped would happen didn't happen. What I'm going to do right now is get rid of begin shape, end shape. And I'm just going to put little spheres. So I'm going to say push, pop. I'm going to say translate v1.x, v1.y, v2.y. And I'm going to say just make a little sphere. That's like 10 pixels big. And all of this is fine. This is fine. I think. Yep. Yep. Let's see what happens here. Oh, you know what I need? I need to also have at the beginning translate to. Oh no, P5JS in 3D starts in the center. What's the error that I'm getting? Cannot read property push of undefined. What did I get wrong here? OK, first of all, cannot read property push of undefined. Why would push not work? In the last for loop, use j as less than loop. Now everything seems fine. Oh, wait. Hold on a sec, everybody. Oh, what is going on here? Vertex. It's still trying to render vertices. Ah, there's a vertex call here. Thank you. Ah, OK. So you can see how slowly it's running because I'm drawing a lot of spheres. But we've got something resembling the super shape there. Does it look right? I cannot tell. Let's see if maybe if I do a box, it'll be a little bit faster. And let me make this 25 so we don't have as much detail. There we go. So this now, and I'm trying to do the Peasy Cam thing. Let's just rotate along the, let's rotate this along like the x-axis, just so we can see it spin around itself. It looks very flat to me. What did I miss? Oh. v1.z, there we go. OK, there's that super shape. It's definitely working. Let's make it the R a little bit bigger. And let's make the boxes a little bit smaller. So you can see that that super shape is there, and that animation is happening. I just want to kind of turn off some of the craziness right now and have this move slower. So you can see there is the super shape, and I think it would also be advantageous for me to just say, whoops, Fill 255? Whoops. Really? Why can't I put a fill in the box? Is it because it has a stroke? So as you can see, there are some bugs. Or, I mean, I could easily be doing something wrong. So I'm not sure what's going on there. OK, so that, yeah, I could draw the mesh myself with lines. I don't think there's 3D lines in P5.js. So I don't know what. Let's look at the P5.js documentation. P5.js begin shape. Let's look at the reference. So I think I don't want to maybe publish this as its own video. Triangle strip is there, but it's unclear what is available in WebGL. Let's make a, let's do something smart here, which is comment the whole thing out. Just say create canvas. Let me give my setup again. Oh, you know what? I bet you the HSB mode is messing up stuff, but let me check that late in a second. Oh, that could be the whole problem. It could be that the HSB mode is like messing up stuff, but let me just do a little test here. This is a useful video for like sort of debugging these kind of problems. So we need to make a simple example that just begin shape. So let's just make a little simple triangle. So let's say let's set a vertex at 0, 0, 0, then a vertex at 100, 0, and then and then let's set a vertex at 0, 100, 0. So this should give me, if I go back to my sketch, okay, yeah, so, So it appears to me that begin shape and end shape, what if I do like triangle? What if I do quad? Oh, I wonder if it could be that like, oh, whoops. Could this be a problem that I forgot that? So I think just that in this current version, I don't know, I have to research whether, hold on. 0, 0, 100, 0, 100, 100, let me add that in. Let's see, oops, oh, whoops. I'm trying to go clockwise. Am I supposed to go counterclockwise? Yeah. Quad is not defined. Ah! Aha! I see a shape. So maybe fill and stroke are not, maybe it only works with textures. That's possible. Or maybe, do these have to be inside? And I'm just stupidly putting them outside? Nope. So there's an issue with setting the colors. Maybe I have to do textures and something, but this is promising. So I did get something. And if I make the background white, we can see it a bit more. So now let's go back. So hold on, does triangle strip work? It did something. Now how do I make the triangle strip that I want would be 0, 0, 0. Then I want to go down. Then I want to go across. And then I want to go back down. So let's see what this does. Yeah, that shouldn't have made two triangles. Does lights work, by the way? Nope. So lights is not implemented, although there's probably some other lighting things. Okay, so now that I see that that works, let me put this whole thing back now. And I should be able to put these vertices back. And take these boxes out, put the begin shape an end shape out and get rid of all the strokes and fills anywhere. Got rid of lights. Let's see, maybe I need, oh, do I not have the background anymore? Or let's make the background white. There it is. So I do have the Supershape working here. And let's look at the P5GIS. Let's see if there's some stuff that we could add by looking at the reference. Or maybe let's look under libraries and see if, is it under WebGL here? I forget where on the P5GIS website the WebGL stuff is. Reference, lights, camera. This would be ambient light. So let's just try to use ambient light. Oh, because maybe I can just do this with some light. Let's try this. See if that works. Whoop. I don't know, this is a bad sign that I'm getting all these errors. Huh. Okay, that's interesting. Maybe, is the ambient light like a color? Ambient material, I wonder what that is. I should read the reference page. Let's go back and read the reference page. Ambient light, green or saturation value, blue or brightness value, red and opacity. What's ambient material? Ambient material. And probably that light maybe is wherever you've translated to. Where's ambient material? Oh, ambient material. Point light. Ooh, point light would be a good idea. As I could point at the object, like a spotlight. What is ambient material? So I guess you have to know what these things are. I don't know anything about 3D. Okay, I think I'm going to play around with this more on my own. You guys can play around with it too and see what you can get working. And maybe we'll file some GitHub issues of things that we've found that maybe don't work here. I'm not going to release this as its own standalone video. I'm going to wait until this will just live in the archive of the live stream. But I will work on this code and try to also release a P5GIS version of it. You know what would be fun to do? Is to port the PZCam library to P5GIS. PZCam library I find to be so useful because it just immediately I can kind of control and manipulate the scene. Okay, it is 3:10. I think that this live stream has happened probably for almost, if you add up all the sections, and I think I started around 12:45, so I'm approaching 2.5 hours. So I think that's been good. So please, do you have any questions you want to ask in the chat? I will remind you that you can, for those of you who might still be here, you can go to codingrainbow.com and at codingrainbow.com you can subscribe on YouTube. You can become a patron on this Patreon site, which is joining our Slack channel for discussion. And you can also subscribe here with your email to get email alerts when I'm doing a live stream. I'm hoping, and then schedule-wise, I will be back on Thursday with another live stream, topic to be determined. So feel free to go to the GitHub, Coding Rainbow GitHub topics issues list. So you can take a look at these topics and upvote them or ask your own questions here, and I will look through and pick some things for Thursday's live stream. The Riza link, I will just show it to you again. It'll just show up in the descriptions, but if you're interested in, I would just Google Riza Ali Supershape or Riza. I bet you if you Google Riza Supershape like this, it's the first thing that's going to come up. There's 2D and 3D, but the page that I'm in particularly looking at, this is the URL for referencing Riza's great work. I know you can't see it right now. There's that URL. Other questions? Topic, jellyfish animation. I like that. That's a kind of big project probably to do. I would probably use toxic libs or some kind of Verlet physics engine to get springy, spongy looking things. Lejeune Renard writes, material is the fill of WebGL texture color. Okay, that's interesting. Okay, if I don't see any more questions, I'm going to go. You're all welcome to that weird green screen footage that I made earlier if you want to make some weird music video stuff. I do have a Coding Rainbow theme song that's coming. I kind of want to record some green screen stuff for that, which is not just from here up, but in this room I don't have the capability of doing that, so I might go somewhere else to do that. All right, I'm just vamping here, talking to see if there's any last questions. Let's see, is anybody still watching? There's 67 of you here, somehow enough. Okay, so I think I'm gonna go. I'm really glad to have done this Supershape stuff. I feel like that was kind of a looming thing. And also, like, I have to admit, when I looked at it, I was like, I don't know if this is ever gonna work. I'm sure I missed lots of details and things that I got slightly wrong or said wrong, but hopefully those videos will get published and be useful. And I will see as many of you that can make it. Right now I'm looking at doing 10:30 a.m. Eastern on Thursday, but I will post updated times to Twitter and also that email list if you want to sign up. Okay, and thanks a lot. I'm going to type goodbye in the chat. After I'm going to turn off the stream, hit stop, and make sure I have all the files. And later, probably this evening or tomorrow or the day after, you know, it takes anywhere between 12 and 72 hours to get the archive of the live stream up. And then also, it'll be a little bit more complicated today for Mathieu to do because there's like a bunch that have to get stitched together. And then also the individual videos, I think there'll just be 2 today, a sphere geometry and a Supershape video. Okay. So somebody asked in the chat, I'll answer this question. How long did it take you to get proficient in JavaScript? Well, I would say about 1 year. But that is with about 10 plus years of Java programming experience before I started doing anything in JavaScript. So I think it took me a year, and I don't even know if I'm that proficient in JavaScript. I do things in weird ways because I'm like an old person who doesn't think in this new kind of like functional JavaScript programming thing. Okay. Yeah, I'll port it to assembly on the next live stream. Okay, gotta go, bye.